Sorry about that. I thought my phone was on Do Not Disturb, and then it wasn't. All right, I think I left off with cubing 2 and getting 8 and cubing 3 and getting 27. Before I multiply the 4 and the 8 and the 3 and the 27 together, I'm going to look down vertically, up and down vertically, or across diagonally to see if I have any common factors. Well, 4 doesn't divide into 3, nor does 4 divide into 27. 8 does not have a common factor with 3, nor does 8 have a common factor with 27. So that just tells me I'm just going to have to go ahead and multiply the two numerators together, get 32 pi, multiply the two denominators together, and I believe that's 81. Okay, part C. Now we have to put in 3r wherever we see r in the original problem. So 4/3 pi, and then don't forget we have to cube our input value. That's what we're doing. So 3r cubed. Quantity 3r cubed. I'll probably manage this constant multiplier, 4 pi. Remember, pi is not a variable, it's a constant. It's an irrational number, but it is a number. 4 pi over 3 times, and let me manage this right here. Now I know that I'm not going to get a fraction here, but I might as well go ahead and build one just in case. I need to cube 3, so I get 27, and then the r is also cubed. Before I multiply 4 and 27, let me see if 3 has a common factor with either of the numerators. And yeah, 3 goes into 3 once, and 3 goes into 27 9 times. So your new denominator is just 1. So I'm not going to make a fraction here since all I have left are 1s in the denominator. So 4 times 9, 36, then the pi, and then the r cubed. All right, changing gears just a little bit here. All right. This next example says complete the table. So we have h of t is equal to the absolute value of t minus 6 over the same t minus 6, but without the absolute value. So something interesting is going to happen because we have t minus 6 on top and t minus 6 on bottom. We do have absolute value around the t minus 6 on top, but something neat's going to happen over here. You're going to see what happens. If I were you, I would stop the video and I would try and evaluate the h of t function for all these different t values and seeing what your answers are. See what you get. Come back and check. First input value is 0. So when t is 0, t goes here is 0, 0 here, and 0 here. So I'll have 0 minus 6 on top and 0 minus 6 in the denominator. All right, well, 0 minus 6 is negative 6, but we're going to have to take anything that's negative and make it positive because of the absolute value. So negative 6, absolute value is 6, but in the denominator, in the absence of any absolute value bars, we're still going to have negative 6. So notice that these two numbers are opposite of each other. When you divide them, you're going to get negative 1. All right, let's evaluate h at 1. Well, 1 minus 6 is negative 5, but you got to turn around and make that negative 5 positive, but the denominator stays negative 5. So this quotient is also negative 1. Predict what you think this answer is going to be. Can you fill in this output value without doing all the computations here? Of course, you can use your calculator. That's absolutely fine. But based on patterns and structure, what have we seen so far? Well, this is actually, if you remove the absolute value bar, you're going to get positive 1 because you have a number divided by its same self. But the question is, okay, look at the value in between the absolute value bars here. Think about 5 halves as being 2.5. When you take 2.5 and you subtract 6, you're going to get a negative number, but then you turn around and you make it positive because of the absolute value. But in the denominator, okay, this is going to stay negative. So we're really back to these previous two situations where you're going to have a positive number divided by its opposite, so this value should be negative 1. What happens when we have an input value of 15 halves? Oh, No absolute value down here. And my eraser's gone. All right, let's think about this for a minute. I'm going to come up here. Well, think about 15 halves is 7.5, because 15 divided by 2 is 7.5, 7.5. 7.5 minus 6 is 1.5. It's positive, so the absolute value bars are unnecessary in the numerator. In the denominator, same thing, it's 1.5. So what's 1.5 divided by 1.5? Is 1. What do you think the answer is going to be when you put in 8, which is a number bigger than 6, in the numerator? Are the absolute value bars necessary? No, because the value in between here is already positive. So you're going to get the same number divided by itself, so that output value is 1. Just kind of an interesting little function there, that your answers are either -1 or 1 as long as you don't put in 6. Think about what happens when you do put in 6. What if I put 6 in the table as a t-value? Well, you're going to get 0 over 0, and that's what we call in calculus indeterminate. Indeterminate. Right. Kind of a neat little function there. All right, let's look at 4, 5, and 6. The directions change, so if you need a brain break, cut me off right now. Go take a little brain break. If you're ready to forge forward, we're going to find all values of x such that f of x equals 0. So just think about that for a minute. Think about what are you going to do when it tells me f of x is equal to 0 and I have to find the x's. Yep, everywhere you see f of x, you replace f of x with 0. Here's a common mistake students make. On these problems, you know what they do? They plug in 0 for x. Nowhere in these instructions is it telling us that x equals 0. It's saying find x so that y, or f of x, is equal to 0. That's the biggest mistake students make. They'll put a 0 right in here and get an answer of 15. That's wrong. X is not 0. I mean, it might end up being 0. But the language of the question is f of x equals 0. How do we solve this? Well, I'm going to add the 3x to the other side. So I'm going to get 3x equals 15. I'm going to divide by 3. So my answer is 5. So that's the answer right there. If you wanted to put this in an ordered pair form, think about it. A point form, your x goes first, your y goes second. X would be 5. What's y? Well, y is 0 because we were told to let y be 0. So 5, 0 is a point on this f of x graph. Right, same directions. If f of x is equal to 0, you replace f of x with 0. Don't replace the x's with 0. That's not what it's saying. All right, how do we solve for x? Well, based on our algebraic background, I see a common factor here. Don't move the 4x to the other side and divide out by an x. You can't divide by a variable because then you might be divided by 0 if that variable is 0. Oh, that was a mouthful. All right, let's take out the common. It's quadratic. It's not a linear equation. So let's go ahead and take out that common factor. Divide out an x here, pull it up front. Now, either x is the 0. There you go. There's one solution. Or the other factor, x plus 4 is equal to 0. So I have a little more solving to do here. Let me subtract a 4 to both sides. You don't have to show this step right here, this mathematical step. So what does this tell us? Well, I have two answers. I could write them as ordered pairs. For this solution, first of all, this x-intercept, another way to think about this is an x-intercept. When x is 0, y is also 0. When x is -4, it means that y is also 0. Remember, y is 0. All right, let's look at 6. All right, to solve this for x, there are several ways you can approach this. Some students might say, well, can I multiply both sides by 5? Absolutely. For me, what I do is I take this 0 and I make it a fraction by putting it over 1. That way, when I have a single fraction here and just 0 over 1 here, I can cross multiply. So 0 times 5 is still 0 equals, and then 1 times the numerator. This should be an easy solve. All we have to do is add 4 to the other side of the equation and then divide by 9. So I'm going to add the 4 to the other side, divide by 9, so x is 4/9. All right, and so the way the question is posed to me, find all values of x, it's not asking me to find an ordered pair, but just remember that the ordered pair associated with this answer is 4/9 and 0, where 0 is your f of x value, which we were told f of x is 0. We were never told that x was 0. Y was 0. Okay. All right, at this point, I'm going to stop this video and I'm going to start another one so we can finish the back page.